All right, so welcome to our notes on writing equations from complex solutions. So notice that we start off with a lot of problems for you to try on your own. So go ahead, pause the video, try those. And then if you have any questions, you can reach out or just look at the answer key and see if that answers your questions. So here are the solutions. Here are your answers. You can pause the video if you want to check those. All right. So what our notes are on today is you are going to be writing equations given solutions. Okay? And we're going to get to complex solutions, but we'll start off with just real solutions. So if we fast forward to the end here, here's an example of what we're doing. Write a polynomial function p of x of least degree with real coefficients in standard form that has zeros of -4 and 2 plus 4i. So those directions can be a little overwhelming, but if we break it down, it should not be so that bad. So you're writing a function, p of x. I'm giving you the name of it. It says least degree. What I mean by that is I don't want you to make up more zeros than what I gave you and add them on, multiply them onto your answer. No one's going to do that, but it's just in the directions. Real coefficients, that's just reminding you that we don't want imaginary values in our answer, in our equation. We actually want integer coefficients. And then in standard form, so our final answer, we want written from highest exponent to lowest exponent, and you're not going to leave this in factored form. You're going to multiply it out, okay? So that's what it looks like. Before we do an example here, there's the linear factorization theorem. It just says that every complex polynomial function can be factored into linear factors, not necessarily distinct, meaning they can repeat of the form f of x equals. And if you looked, this is just factored form. So here is an example. It says, write a polynomial function f of x. So I'm going to start off by saying for this one that this is going to be f of x equals of least degree with real coefficients in standard form that has the zeros of 1, 2, and 3. So I'm giving you that there is a 0 of 1. So when I set this factor equal to 0 and solve, I get 1. So I'm going to write down what that factor is, and that factor is x minus 1. Right? Likewise, if you have a 0 of 2, that means we have a factor of x minus 2. And if we have a 0 of 3, we have a factor of x minus 3. Now, we're not leaving our answer like this because this is factored form and we want standard form. So what we're going to do now is we're going to multiply it out. So I'm going to start by multiplying these two factors. And I could have picked the last two or the first and the third one, but why not just do the first two, right? So I'm going to multiply those two out. X times x is x squared. X times -2 is -2x. -1 times x is -3x. So I multiplied those out and combined them. And then -1 times -2 is +2. And then I'm going to still have to multiply that by x minus 3. Okay? So you have a choice of how you're going to do this. I'm going to do it the way that I would, and then I'll show you another way. So I'm going to distribute this x squared to each of these terms first. So I have x squared times x is x cubed. X squared times -3 is -3x squared. I'm now going to distribute my -3x. -3x times x is -3x squared. -3x times -3 is +9x. And then lastly, I'm going to distribute this 2. So 2 times x is 2x. 2 times -3 is -6. Lastly, I'm going to combine like terms. But before I do that, I want to point out another way you could have done this, is that you could have distributed x minus 3 to each of your other terms. So I could have done x times x squared is x cubed. X times -3x is the -3x squared, which is right here. And x times 2 is 2x. Then I could have distributed the -3 and got -3x squared. -3 times -3x is my +9x, and a -3 times 2 is a -6. So it doesn't matter which way you do it, you're going to get the same terms. All right, so I'm ready to write my final answer. F of x equals, don't forget your f of x equals. And then standard form, so highest exponent to lowest exponent. I have my x cubed. I'm going to combine my squares. And actually, before I do this, you should always look for a pattern. So notice I got a cube and a square and a first power and an x to the 0 power. And if I didn't have some sort of pattern, I probably messed up with multiplying. All right, back to what I was doing. A negative 3x squared and negative 3x squared is a negative 6x squared. A 9x and a 2x is 11x. And then a negative 6 is my constant, and there's my polynomial function. Voila. Okay, and then before we move on to introducing complex zeros into this, what you need to know is the conjugate pair theorem. The conjugate pair theorem says is that if a plus bi is a 0, we know that a minus bi is also a 0. They come in complex conjugate pairs. So if I just give you one of a complex zeros, you can assume the other one is there too. So what do I mean by that? Here it says information is given about complex polynomials whose coefficients are real numbers. Find the remaining zeros of f. So I'm telling you it's a third degree polynomial, and I'm telling you there's a 0 of 2 and 1 plus 3i. So that means I forgot to give you one and forget, but you can assume the other one, 1 minus 3i. So its complex conjugate is also a 0. Fourth degree polynomial, I gave you the 0 of negative 4, 1/2, and negative 4i. Well, also positive 4i has to be a 0. Here, degree of 5, a 0 of 1, and then I said 2 plus I, so that means 2 minus I is also a 0. Negative 5 minus 2i, so negative 5 plus 2i is also a 0. Remember, the conjugate is just changing the imaginary part. All right, using that, I have 2 problems for us to try. That's it, right? Oh, nope, 4 problems for us to try. So I'm going to do the first 2 with you, and then you can try the last 2 on your own. When you are trying the last one on your own, multiplicity of 2 means that it repeats twice. So that 0 happens twice. Okay, so let's go ahead and try this one here. A polynomial function g of x. So g of x equals, and then we are going to write our zeros. Or sorry, we're going to write our factors. There is a 0 of negative 3, so that means that there is a factor of x plus 3. There's a 0 of 2i, that also means that there's a 0 of negative 2i, so I'm going to write those 2 factors. X minus 2i and x minus a negative 2i, which turns to x plus 2i. I'm saying it like that, strangely enough, because when we get to a little bit more complex ones, we are going to, when I explain it, it'll make more sense then. Okay, I'm not going to start off by multiplying these 2. The reason I'm not is because remember when we multiply conjugates, amazing things happen. So I'm going to start by multiplying the conjugates here, okay? So I'm going to leave the x plus 3 in front, and I'll worry about that after I multiply these 2 conjugates. So when I multiply the conjugates, x times x is x squared. This is 2ix, and this is negative 2ix. Remember, those cancel. And then I have negative 2i times positive 2i, which is negative 4i squared. And then negative 4i squared is the same thing as plus 4. So now I have x plus 3 times x squared plus 4. This is still not in standard form. This is still factored form, so we're going to multiply this out. So I have x times x squared is x cubed. Sorry, that's correct, yes. And then I have 4 times x, which is 4x. I'm going to write that here because I know that I'm going to do this one right here, which is 3x squared. I want to write it in standard form right away, but you can take an extra step to do it. And then 3 times 4 is 12. Oops, I almost forgot my g of x before I boxed. So there's my final answer. G of x equals x cubed plus 3x squared plus 4x plus 12. We're actually going to do example 4 and example 5 because I just realized example 5 is much more difficult than example 4 and example 3. All right, so I gave you zeros of 5, 2, and I, so you can assume negative I. And now I'm going to write my factors. So we have h of x equals, And then if 5 is a 0, x minus 5 is a factor. If 2 is a 0, x minus 2 is a factor. And if I is a 0, x minus I is a factor. And if negative I is a 0, x minus a negative I is a factor, which we're just going to say x plus I is a factor. Okay, so now I'm going to multiply this out. I'm going to multiply these two, and I'm going to multiply these two in my first step. So x minus 5 times x minus 2, that's x squared minus 7x plus 10. And then x squared x minus I times x plus I is x squared minus I squared, which I can change that minus I squared to a plus 1. So we have x squared minus 7x plus 10 times x squared plus 1. And now I'm going to multiply this out. Okay? Be careful. Watch for mistakes here. Just try not to make them. They're hard to catch if you're not paying attention. All right, so I'm going to do x squared times x squared is x to the 4th. X squared times 1 is x squared. Now I'm going to distribute my negative 7x. Negative 7x times x squared is negative 7x cubed. Negative 7x times 1 is negative 7x. 10 times x squared is 10x squared. 10 times 1 is 10. I'm going to check for a pattern just to make sure I didn't make any mistakes here. I have 4th squared, 3rd to the 1st power, 2 no power. Okay, I think I did okay. And now I'm going to combine like terms, and I'll have my final answer. H of x equals x to the 4th. I have a negative 7x cubed. This looks like a minus there, so I'm going to fix that. So that's a negative 7x cubed. I have an x squared and a 10x squared, which is 11x squared. And then I have a negative 7x and a plus 10. And there is my final answer. All right, we're going to do 5 together, and then I'm going to have you try 7 on your own, but then I'll actually do 7 since, in case you did get stuck and you can't find your mistake. All right, so P of x equals, I have a 0 of negative 4, so that means I have a factor of x minus a negative 4, or x plus 4. I have a 0 of 2 plus 4i. That also means I have a 0 of 2 minus 4i. All right, so if I have a 0 of 2 plus 4i, that means I have a factor of x minus 2 plus 4i. Now, 2 plus 4i is 2 terms, so I have to make sure I put it in parentheses so I can distribute that negative to each of those terms. I can't just say minus 2 plus 4i. Then I have x minus this one right here, which is 2 minus 4i. That's 2 terms, so I want to make sure I write it in parentheses so I can distribute that negative. Speaking of distributing that negative, let's go ahead and do that right now. So I have x, distribute your negative to those 2 terms, so it's minus 2 minus 4i, and distribute your negative to those 2 terms, so I have minus 2 plus 4i. Now, I'm going to multiply these 2 first because they are conjugates. And remember, when multiplying conjugates, beautiful things happen. Be very careful. All right, so I'm going to do x times x is x squared. X times negative 2 is negative 2x. X times 4i is 4ix. Now I'm going to distribute this negative 2. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. Negative 2 times 4i is 8i. Sorry, negative 8i. Now I'm going to distribute this negative 4i. Negative 4i times x is negative 4ix. Negative 4i times negative 2 is positive 8i. Negative 4i times 4i is negative 16i squared. Whew. All right, so first thing I see is this negative 16i squared right here. Remember, I squared is the same thing as negative 1, so I'm going to cross this off and change it to positive 16. Okay? All right, so now the amazing things that happen. The amazing things that happen, right? 8i and negative 8i cancels out. Negative 4ix and positive 4ix cancels out. Remember, amazing things happen when you have multiply complex conjugates. All right, or any conjugates for that matter. So this is x plus 4, and now we're going to combine like terms. So we have x squared, we have a negative 2x and a negative 2x, which is a negative 4x. What you should notice when you do this is you always have two of the same thing. So it's never going to cancel out. It's just you're going to have like negative 3x and negative 3x, positive 2x and positive 2x, something like that. And then you're always going to have like terms to combine here. So a positive 4 and a positive 16, which is positive 20. Now you are going to multiply this out, combine like terms, and you will be done. So just be careful. X times x squared is x cubed. X times negative 4 is negative 4x squared. X times 20 is 20x. Now I'm going to distribute that 4. I have 4x squared minus 16x plus 80. Look for a pattern, 3, 2, 1, 2, 1, 0, okay? And now I'm going to write my final answer with combining like terms. X cubed is first, then my squareds comes next. A negative 4x squared and a positive 4x squared cancel out. I have 20x and negative 16x, which is plus 4x, and then plus 80. All right, there's your final answer. All right, why don't you pause the video and try the last one on your own. Once again, multiplicity of 2 means that this 2 happens twice. So that 0 is happening twice. A 2, a 0 of 2, and then a 0 of 2 again. All right, let's see how you did. I'm going to go through it, and you can fast forward to the end to see how you did if you want to check first. But if you didn't get it right, then you can watch this part. So there's a 0 of 3 minus I, so that also means there's a 0 of 3 plus 3i. So I'm going to write my factors. This is q of x. So q of x equals x minus 3 minus 3i and x minus 3 plus 3i. And then we have x minus 2 and x minus 2. All right, I'm going to clean up these first two by distributing that negative. So minus 3 plus 3i, x minus 3 minus 3i. And then I'm going to multiply these two while I'm here because I just feel like it. So that's x squared minus 2x and minus 2x is minus 4x, and then plus 4. All right, now I'm going to multiply these conjugates here. So I have x times x is x squared. That was this. X times negative 3 is negative 3x. That is negative 3ix. Now I'm going to distribute this negative 3. That's negative 3x, positive 9, and positive 9i. Now I'm going to distribute this 3i. That's positive 3ix. That's negative 9i. And this is minus 9i squared. And then don't forget your x squared minus 4x plus 4. All right, clean up this first set here. So I have a negative 9i squared, which is positive 9. This negative 9 and this positive 9i cancel. This negative 9i and positive 9i. 3ix and negative 3ix. And then we have x squared minus 6x, a 9, and a 9 is plus 18, times x squared minus 4x plus 4. Now let's just multiply this out and see what we get. X squared times x squared is x to the 4th. X squared times negative 4x is negative 4x cubed. X squared times 4 is 4x squared. I see the pattern of 4, 3, 2 there. It makes me feel good. I'm going to distribute this negative 6x now. Negative 6x times x squared is negative 6x cubed. Negative 6x times negative 4 is positive 24x squared. Negative 6x times 4 is negative 24x. I see a pattern on the exponents of 3, 2, 1. Once again, makes me feel good. 18 times x is 18x squared. 18 times negative 4 is negative 72x. And 18 times positive 4 is 72. I look at the exponents, that's 210. Makes me feel pretty good. All right, ready to write my final answer. Q of x equals standard form, highest exponent first, x to the fourth. I have a negative 4x cubed and a negative 6x cubed, which is negative 10x cubed. I have a 4x squared, a 24x squared, and an 18x squared, which is 28, 38, 42. Nope. 28, 38, 46x squared. Sorry. Then I have a negative 24 and a negative 72x, negative 24x and a negative 72x, which is negative 96x. And then I have plus 72. I lost my 2 on my 72. All right, there is your final answer. Hopefully you got it correct. If not, hopefully going through it with you helped a little bit. All right, you can go ahead and work on some homework.